keeping up with like everything happening out there, it's a lot, right?
Yeah, definitely
Yeah.
feels like a full-time job sometimes.
Yeah, exactly. So that's why, I mean, we do this, we carve out this time to
Okay.
really dig into something, really
Yeah.
fascinating and pull out the nuggets that matter.
Absolutely.
And today we're diving into a corner of audio technology that's
Oh.
really kind of exploding right now.
Yeah.
And it's called Zero-Shot Multi-Speaker Text-to-Speech, or TTS.
That's right.
It's a bit of a mouthful, I think, but
It is a little bit.
but the underlying concept is so captivating.
It's really cool.
So imagine being able to capture someone's voice
Yeah.
from just like a few seconds of audio,
Uh-huh.
and then using that to generate speech
Yeah.
in their unique vocal style.
Right.
I mean, that's the core of Zero-Shot Multi-Speaker TTS.
Yeah. That's exactly right.
And I guess to break it down a little bit, Zero-Shot means it needs almost no training data for a new voice.
Right.
And then multi-speaker means it can learn to mimic many different voices.
Yeah, exactly. That's the idea.
Okay, cool. So to really kind of get into this and see where this is going,
Uh-huh.
we're focusing on a discussion from the 2022 Speech AI Summit,
Okay.
specifically a presentation from the team at Koki.ai.
Great.
I mean, they're really at the forefront of this field, right?
Absolutely. Yeah. They're doing some really cutting-edge work.
So our goal for this deep dive is to really unpack this for you.
Right.
To understand what makes it such a leap forward,
Yeah.
what it can do now, what its capabilities are,
Uh-huh.
and to make it both understandable and genuinely interesting.
Absolutely.
Okay, so let's get into it.
Yeah. Let's dive in.
What's the fundamental breakthrough
Okay.
that has paved the way for Zero-Shot TTS?
Well, the idea of computers generating speech isn't new, right?
Right.
But what we've seen recently, the big advances are really due to deep learning. These sophisticated neural networks that are so good at recognizing patterns in audio.
Uh-huh.
And Zero-Shot Multi-Speaker TTS takes this a step further.
Right.
It's not just converting text to sound.
Right.
It's doing that with the specific vocal characteristics of an individual
Uh-huh.
based on a tiny audio sample.
Right.
And that zero-shot aspect
Mm-hmm.
means the model doesn't need a ton of training on that particular voice.
Wow. Okay, so the Koki.ai session at the summit, they really got into, I guess, the present capabilities and the future trajectory of all of this.
Exactly. Yeah, they really explored the evolution of the technology,
Okay.
and they showcased some of the most impressive achievements so far.
Okay, which brings us to some of the key achievements.
Right.
One that stood out was your TTS.
Uh-huh.
What makes that significant?
Well, your TTS has shown really high-quality performance in English.
Okay.
But what's truly groundbreaking is it can do the zero-shot multi-speaker stuff
Yeah.
in new languages, even if the model's only been trained on a little bit of data in that language,
Okay.
like maybe even just a single speaker.
Oh, wow. So you could potentially generate speech in a less widely spoken language using just a small audio snippet from one speaker.
Exactly.
I mean, think about the ability to create educational materials,
Yeah,
preserve oral histories,
right.
allow individuals to communicate digitally in their native tongue,
Uh-huh.
all with just minimal recordings. I mean, this has the potential
Yeah.
to revitalize endangered languages
Totally see.
in ways we just haven't seen before.
Yeah, it's really exciting.
And if we connect this to the bigger picture,
Yeah.
I mean, you can immediately grasp the implications for low resource languages.
Right.
Consider indigenous languages, for instance, where extensive speech data sets might not exist.
Exactly.
I mean, this could be transformative for language preservation and accessibility.
Absolutely. Yeah, it has the potential to really change things.
That's huge. I mean, the potential for broader access is just immense.
Yeah.
Now, the discussion also touched on the role of advancements
Okay.
in speaker verification systems.
Uh-huh.
How do those relate to Zero-Shot TTS?
Well, it's fascinating. There's this synergy between these two areas.
Okay.
So speaker verification systems, they're designed to identify or authenticate someone based on their voice.
Mm-hmm.
And the methods used to do that effectively,
Yeah.
to extract those unique traits of a voice,
Right.
those speaker embeddings,
Yeah.
are also incredibly valuable for zero-shot TTS.
Okay.
Think of these embeddings as like a unique digital fingerprint of someone's voice.
Right.
It captures the key characteristics that make it distinct
Yeah.
And better speaker verification models lead to more precise representations of a voice,
Okay.
which means more accurate voice cloning in TTS.
Okay, so it's like having a more detailed and accurate blueprint
Yes.
of the voice.
Yeah.
And then there was this intriguing concept of generating entirely new artificial voices.
Right.
So the idea of creating completely new voices, how far away is that from being like commonplace?
Well, it's moving closer to reality than you might think.
Okay.
This comes from those speaker embeddings that we were just talking about.
Uh-huh.
You can actually generate new speaker embeddings.
Oh, wow.
Essentially create novel sets of vocal characteristics.
Okay.
These can be totally random, or
Yeah.
even like a blend, an interpolation
Uh-huh.
between the embeddings of existing speakers.
So you could, in theory,
Yeah.
combine the vocal qualities of two different people
Right.
to produce a completely new voice.
Exactly.
Wow. Beyond just copyright,
Yeah.
what does this mean for things like digital avatars?
Oh, that's a great question.
Could we choose a voice
Yeah.
that perfectly represents our virtual persona,
Uh-huh.
but distinct from any real person?
Precisely.
Ah,
And the Coqui.ai session highlighted that
okay.
this could lead to generating voices that wouldn't be subject to copyright restrictions,
Oh, wow.
which opens up a huge range of possibilities for content creators.
That's massive. I mean, that's a game changer right there.
Yeah, it really is.
Okay, so this is where it gets really interesting.
Okay.
The discussion also covered some key questions people have about this technology
Yeah.
and how we measure the quality of these TTS systems.
Mhm.
It's not just about like subjectively listening, is it?
No, it's not.
So we've established how incredible this technology is,
Right.
but how do we actually know if it's good?
Yeah.
Let's get into how the experts evaluate
Okay.
the quality of these zero-shot systems.
Right. Well, the standard way to assess the overall quality and naturalness
Okay.
is something called the Mean Opinion Score, or MOS.
Okay.
This involves having human evaluators listen to the synthesized speech
Uh-huh.
and rate it on a scale from 1 to 5,
Okay.
with 1 being poor and 5 being excellent.
So human perception still plays a really significant role in all of this.
Yeah, absolutely.
But for these zero-shot systems, where the accuracy of the clone voice is so critical,
Right.
how do they measure that similarity?
That's where similarity MOS comes in.
Okay.
So again, human listeners evaluate how closely the generated speech resembles the original voice.
Right.
But they also use a more objective measure
Okay.
called speaker encoder cosine similarity, or SECS.
Wow.
So this uses that speaker encoder to extract numerical representations, those speaker embeddings, from 2 audio samples,
Okay.
the original and the synthesized.
Yeah.
Then they calculate the cosine similarity between these embeddings,
Okay.
which gives you a quantitative measure of how alike the 2 voices are mathematically.
I see.
Think of it like measuring how closely 2 arrows are pointing in the same direction.
Okay.
The closer they are, the more similar the voices.
Interesting. So it's a combination of human judgment and computational analysis.
Exactly.
Now, what about using AI itself to evaluate the quality?
Right.
I know that's a growing area in lots of different fields.
Yeah, it definitely is. Researchers are looking at using artificial neural networks to predict the MOS,
Oh,
which would really streamline the evaluation process.
Yeah.
But the challenge right now is that these systems don't generalize well to new conditions,
Okay.
especially if the recording environment is different from what the AI was trained on.
Yeah.
Things like different microphones or background noise can really affect their accuracy.
Yeah, that makes sense. I mean, the AI needs to be adaptable to real-world variability.
Exactly.
Another question that came up
Okay.
was whether speech-to-text systems
Right.
could be used to assess TTS quality.
Uh-huh.
It seems a bit indirect, but what's the reasoning there?
Well, the idea is you take the synthesized speech,
Yeah.
you put it into a speech-to-text system,
Uh-huh.
and you see if it accurately transcribes what was said.
Okay.
This can be a way to verify the pronunciation.
So it's more about checking if the words are spoken correctly,
Right.
not necessarily like the overall naturalness or
Yeah.
similarity.
Yeah. Of the voice.
STT evaluation mainly looks at pronunciation accuracy.
Okay.
It doesn't tell you much about the overall quality and naturalness
Okay.
of the synthesized speech in the target voice.
Okay, cool. Now, zero shot is the goal, right?
Yeah.
But it can't be perfect in every situation.
Right.
The discussion mentioned comparing it to 1-minute fine-tuning. What's the advantage of that?
You're right. Zero shot is really powerful.
Yeah.
But sometimes the recording conditions or the characteristics of the voice are very different from what the model has seen in training.
Right.
And the initial zero-shot performance might not be great.
Yeah.
The voice might not sound much like the intended speaker.
Right.
That's where 1-minute fine-tuning comes in.
Right.
You give the model a short additional audio sample of the target voice, even just 1 minute.
Yeah.
You can dramatically improve the accuracy of the voice cloning.
So it's like giving the model some extra targeted information to fine-tune its understanding.
Yeah. Of that specific voice.
Exactly.
Okay, and then the discussion emphasized repeatedly the importance of the speaker encoder. Why is that component so vital?
The speaker encoder is absolutely crucial.
Okay.
Because it extracts those unique vocal characteristics.
Right.
It creates these speaker embeddings without a good speaker encoder that can capture the essence of a voice.
Yeah.
The TTS model simply can't clone new voices effectively.
It's like the key that unlocks the ability to speak in someone else's digital voice.
Yeah, good analogy.
And your TTS model utilized a speaker encoder that was trained separately on a massive amount of speaker data, right?
Yes. It was pre-trained on thousands of speakers.
Okay.
And then kept frozen during the training of the main TTS model.
Okay.
So it has this really broad understanding of different vocal attributes.
And the discussion also touched on alternative approaches.
Right.
Where the speaker encoder is trained simultaneously with the TTS model. Yeah, I mean, what are the benefits and drawbacks there?
Well, some research shows that training them together can work well. But I think the point they made in the discussion was it really depends on the data.
Okay.
If you don't have enough speaker diversity in your data set, the model can become too specialized. And it won't generalize well to new speakers or environments.
Right. It's a delicate balancing act.
It is, yeah.
So going back to creating new voices, we talked about blending existing ones, but can we really generate totally novel artificial voices from scratch?
Absolutely. By generating random speaker embeddings.
Wow.
You can create voices that don't belong to any real person.
Okay.
Now, your TTS demos might not directly show this, but they talked about the SC Glow TTS demo as an example.
Okay.
It's really cool. It shows you how you can create these synthetic vocal identities.
It's mind-bending. I mean, it really makes you think about the future of audio content.
It does.
Now, switching gears slightly, when they train these models, is it typically based on phones or characters?
So your TTS uses a character-based approach.
Okay.
Whereas a model like SC Glow TTS uses phonemes.
Okay.
Which are the basic units of sound in a language.
So why characters for your TTS?
The main reason is that it's better for low-resource languages.
Okay.
A lot of these languages don't have good phonomizers, systems that can automatically convert speech to phonemes.
Yeah.
So training on characters avoids that problem.
Right.
It's more practical for languages with limited resources.
That's a really smart consideration.
It is, yeah.
And finally, something that always comes up when we talk about AI, computational power.
Right.
How much hardware do we need to train a TTS model like your TTS?
Well, for your TTS, they used one NVIDIA V100 32GB GPU with a batch size of 64.
Okay.
That gives you an idea of the scale.
Yeah.
But they mentioned that you might be able to train with smaller batch sizes on GPUs with less VRAM.
Okay.
They hadn't tested it extensively, but people in the open source community have reportedly fine-tuned the model.
Okay.
Using GPUs with like 11 gigabytes of VRAM.
So it's computationally intensive.
It is.
But it might not be completely out of reach for smaller research groups.
Exactly, yeah.
Now, a couple more technical questions.
Okay.
About the speaker embedding extraction. Is it beneficial to remove silences or certain types of sounds?
So ideally, the speaker encoder should learn to ignore silences.
Right.
And focus on the speech content. But when they prepped the data for your TTS, they did remove long silences at the beginning and end of audio files.
Okay.
Mostly to avoid problems during training.
Okay.
But generally, they don't remove unvoiced or plosive foams.
Right.
During the actual embedding extraction.
Okay. And one last question from the summit that I think we should touch on. Can Zero-Shot TTS really capture expressive speech? I mean, conveying emotions and nuances.
Absolutely.
Yeah.
It's not just about copying the voice.
Yeah.
It's also about conveying emotion.
Uh-huh.
Koki.ai has actually developed a model that's available through their Koki Studio that can do Zero-Shot Multi-Speaker TTS with 5 different emotions.
Wow.
So yeah, the technology is definitely moving towards more expressive and natural-sounding speech.
So it's not just mimicking a voice.
Right.
It's mimicking how that voice conveys feeling.
Yeah, exactly.
That's huge.
It is, yeah.
So let's recap.
Yeah.
What are the key insights from our deep dive into this Koki.ai discussion?
So I think the main things to remember are the incredible progress in Zero-Shot Multi-Speaker TTS, especially the ability of models like your TTS to clone voices with just a little audio.
Right.
And even do this for languages with limited data.
Yeah.
We also talked about the potential to generate entirely new artificial voices and how these systems are evaluated using MOS and SECS and the vital role of the speaker encoder.
Yeah.
And finally, that even expressive Zero-Shot TTS is becoming a reality.
Yeah. Wow. It's amazing.
It's really fascinating stuff.
It is.
And it feels like we're just scratching the surface.
Yeah, we're really just at the beginning
of the potential here.
Absolutely.
So thinking about the ability to create completely new voices from just a few seconds of audio.
Yeah.
What does that mean for how we think about identity and expression in the future of audio?
That's a huge question.
I mean, that's a question that I think really stays with you.
It does. Yeah, it really makes you think.
It makes you think, and we encourage you, the listener, to consider these possibilities.
Yeah.
And to explore the resources mentioned in the original article.
Absolutely.
If you want to go deeper into this really rapidly evolving field.
It's changing all the time.
Thanks for joining us.
Yeah, thanks for having me.
On this deep dive.
It's been great.
We'll catch you next time.
See you then.